Hello and good morning. My name is David Christiansen and I come from Glasgow in Scotland. By day, I work as a principal technologist for Leidos UK, and by night, I am a geek and a brewer. By show of hands, do we have anyone that's tried brewing beer in here before? Awesome. Another show of hands, how many people have Raspberry Pis? How many people have used those Raspberry Pis? Okay. Sorry, I got earpiece issues. That's fine. I'm here to talk about how I've used my Raspberry Pi to augment my brewing process and make better beer. So I like beer. I like beer quite a lot. I also spend a lot of money on beer. So the natural progression for me was surely it's going to be cheaper if I brew my own. So I went to the local supermarket, bought the in-the-box home brewing kit, followed the vague instructions and waited patiently for a couple of weeks. And it's safe to say that what the results were absolutely revolting. They were undrinkable. But that didn't put me off. What that made me decide was I'm going to do what the brewers do. I'm going to use the same ingredients that real brewers use, and I'm going to use the same process. And that process is all grain brewing. Now, you can do all grain brewing in your house. Indeed, you can do it in your kitchen. However, that might not go down well with everyone else who lives in the house. So that's why I ended up in the garage. Brewing can be straightforward. It can be straightforward. But in practice, it can be quite challenging. And by no means is technology a substitute for experience and trying and gaining skills. But where technology can help is in one of the key principles of successful brewing, and that is consistency, as with so many things. So what I wanted to do was apply some of the principles from my day job, and I apply that into the brewing process, and that is mainly automate and instrument as much as possible so it can be repeatable. So of all the ingredients that are involved in brewing, yeast is the one that we really care about. Yeast is a very sensitive microorganism, and it is particularly sensitive to temperature. So it's temperature that we're wanting to use technology to monitor and control. But before we start to use yeast, we need to prepare the liquid that we're going to ferment with yeast. And for that, I use a grain father. The grain father is actually a fantastic bit of kit. The more recent versions are actually Bluetooth controls from your iPhone or Android. You put in your recipe, all the ingredients, hit start, and it will guide you through the whole mashing, sparging, boiling, whirlpooling process. The result of which is a lovely sugary liquid, which yeast is desperate to start eating. And that process is called fermenting. Fermenting takes place within a temperature-controlled fermentation chamber, otherwise known as a fridge. And for that, we need to hack a fridge. Word of warning, it's best that you go out and get a second-hand fridge. Hacking your household fridge does not go down well. So what we're going to do, we are going to take control of the fridge's compressor so we can cool things down. We're going to install a heater so we can heat things up. We're going to install some sensors, and all of that will be wired into initially an Arduino, and the Arduino will be connected to a Raspberry Pi. Now, hacking a fridge actually isn't as complex as you may think. Essentially, all we're doing is putting in two relays that we can control, one for the heater, one for the chiller, the compressor. The code that's controlling that the relays is from a project called BREWPI, made by a very nice gentleman called Elko Jacobs from the Netherlands. And what BREWPI does is it can do everything from entry-level monitoring of environments all the way through to full brewery automation, which I hope to demonstrate later if I've got time. The result of which is something like this. Now, this is from a brew I did earlier this year, and all those squiggly lines is the system trying to maintain a consistent temperature in my wort, which is the fermenting beer. So, given that data, that got me excited. I'm like, what else can I do with that data? And this is where InfluxDB and Grafana come in. InfluxDB is an event-based event database. It's built for storing data coming from monitoring devices and Internet of Things devices. And Grafana is a fantastic data visualization tool for creating dashboards, and it also has monitoring capabilities and alerting. Fantastic. And it looks a wee bit like this. Now, I have a demo of this, but I'm not going to have time to show you, but if you're interested, I can show you later. Really very simple to put things together. So I've now got my InfluxDB and my Grafana all running on my lovely Raspberry Pi here in Docker, all the technology. What else can I do now? So I start looking at other Wi-Fi-enabled chips. The BREWPI project moved away from the Arduino platform towards particle photons. So I did the same. And initially, I just rechip, and it's a fantastic little device, which is going to fall off the table. Fantastic little device. Once it's on your home network, it synchronizes to Particle, and you can use the cloud-based IDE to write software and deploy to the device on your desktop. This code and setup is a simple temperature monitor which throws data into Influx database. Absolutely fantastic. The next one I looked into was a WEMOS D1 Mini, which is based on the ESP8266 Wi-Fi chipset. A fantastically versatile little device, especially when you apply it with something called BREWPI, which essentially means that I do no longer need my Arduino. I actually no longer need my Raspberry Pi. Everything runs off a chip like that. So wire it up, create the circuit, you've got a nice little self-contained unit, especially when you combine it with a little device like this, a Sonoff TH10. It is an appliance geared toward home automation, very low cost indeed. And it also has this ESP8266 chipset, which means you can flash it with the BREWPI, plug in your temperature sensor, and plug it into a heater, and that's you got a temperature-controlled unit. In Scotland, you just open the door to cool things down. It's cold. Yeah, so what we're moving away from is boxes of wires and soldering, and more to professional things and nice-looking things like this. And that's exactly what BREWPI did as well. They moved to the Photon and they started developing nice little units, self-contained, looking lovely, with all the connectivity you need. We're now in version 3, or sorry, they're now in version 3, which is launching soon, but I just happen to have an early prototype sitting here. Another really exciting thing that the BREWPI team are working on is a user interface, which will allow you to represent visually your whole brewing process, control valves, control pumps, heaters, monitoring, everything. It ticks all the boxes for me. I do have a demonstration of this, but I'm just going to show you a quick video. Oh, I don't have audio turned in. Oh, no. Where's the... Oh, here we go. Sorry, it's going to go pop. Hopefully we have audio. So isn't that fantastic? So what am I looking into next, just to wrap up, how are we doing for time? What am I looking into next? How do you know when your beer is done? Well, traditionally, you would take manual samples at the beginning of fermentation and through the fermentation process. And when the value stops changing, then you know that the yeast has finished having its meal and you've now got beer, hopefully. One key point is, when I give beer to friends, they go, "Are you going to kill me?" That's the first question. And B, how strong is it? There's absolutely no excuse for homebrew not to be accurate. If you follow calculating the specific gravity and the ABV, then you know exactly what the alcohol percentage is. So there's no excuses for drinking rocket fuel unwittingly. So what do we want to do here? We want to create a digital hydrometer. So this is where we use something like this. Yeah, suspect looking. But what it actually is a unit that sits within the fermentation chamber and continuously monitors the fermentation process. So no more having to go into the garage in your slippers and taking samples and having to drink your beer before it's ready. You can now go onto your screen whilst drinking nice beer and watch it and wait for it to be ready. The last project I'm going to be looking at is, so I've got kegs, and I want to know how much beer I've got left. Of course, I could go lift it, but that's difficult. I've also got a very much unused Wii balance board, which is essentially a Bluetooth-enabled weight scale. So the challenge is to basically use that to send data into the Influx database and use Grafana to perform calculations to say you've got 4 pints left, start brewing. With that, thank you very much. And if we've got time, do we have time? I think, yeah, we do. I'm going to try and do a wee bit of a demo. So whilst that's, I'll put that there. I'll come back to that screen so you can take notes if you want. So what we have here is an instance of BREWPI running, and you can see the temperature. Oh, you can't see it. There we go. So you can see when I started setting up for today, we've got some lovely data coming in. If I switch to my SSH console, you can also see that I'm taking data from BREWPI and spitting it into Influx database. And if we switch here, it's very blank. I might be moving on very quickly. Yeah. Oh, no. Yeah. I'll come back to that one. So this is the UI that I just showed you earlier. So just make sure everything's closed. So let's go in and start my process off and filling the hot liquor tun. So that's what I want to do. What we've got here is a representation of these two valves in the bottom. So when I hit apply, you should get some lovely noise. There you go. So what that is a valve. So I'm now filling that tun with lots of lovely cold water. And let's fill the boil kettle next. Hit apply again. So fantastic. So the UI is actually calculating the flow and where it's going. And let's just close that off and hit apply. So, isn't that exciting? I think it is. So, with that, thank you very much.